this whole time. Like, when you create a list, right, you're creating a new list object, right? Like it's of type list. Once we boot this up, right? And then, if you like type in list parentheses, what are you doing? You're constructing, this is called a constructor, right? You're constructing a new list instance, right? In other words, you're constructing another example of a list, of a particular list. So with an object, when people say like object-oriented programming, what happens is we're building our own like types, essentially. We're building our own types of objects. So for example, we can define one called car. Okay. So what I'm doing here is I'm using the class keyword. This is a Python keyword. And then capital car, and then a colon. And then here I'm just putting in pass, as in, like, it's just like a placeholder, the same way that we saw in functions. And instead of constructing like a new list, I can construct a new example of a car. Okay? So you can think of the class as like a factory because it produces examples, right? Instances. This is an instance of a car. So for instance, let's call this like a Porsche, right? So I'll assign this car instance to a variable. And now we can add attributes to it, right? So I can say like, okay, this Porsche color is yellow. And now if you look at the Porsche.color, it comes back as yellow. So it's kind of almost like a dictionary. We can assign another attribute. Let's say like the Porsche year is 2010. And again, I can do Porsche.year is 2010. I'm assigning all these attributes on this one instance, right? You can't really see it here, like it's kind of hidden. But if I do Porsche.dunderdict, you can see these are the attributes on this particular instance. So far we saw that, we can kind of define a new type of object, right? We have this class thing, and the class allows us to build new instances, right? And then once we have those instances, we can define attributes on them simply with the dot notation. So Porsche.color equals, right? And then so this is setting an attribute with the equals, and then we get it back just with the dot notation followed by the attribute name. And then the last thing we saw was, okay, Porsche.dunderdict, right? That allows us to see all the attributes at once. So just to see it one more time, let's say we build a new car, and this time we'll, Ferrari or whatever. Ferrari.color is red. Okay, and let's just go, and Ferrari.year is like 2010, 2015. So now just the only thing to note really is that these attributes are different, right? Like the Ferrari's attributes are obviously going to be different than my Porsche's. Like this. Attributes. Okay. So every time we do this car parentheses thing, we're constructing, right? This is our factory. We're building a new car, a new example of a car. This gives me back an instance. And now I'm setting attributes on this particular piece of data, on this instance. Questions so far about this?
Jeff, if we have to define a difference between function and the class, how will we do that? I mean, is that like function does not allow creation of attribute, or is there something more to it?
Yeah, we're not really setting attributes on a function, Like, the class returns a piece of data to us, like and it creates a new piece of data that didn't exist before. It creates a new object for us.
No, right? But you can do it with function also, right?
You can
assign.
Yeah, you could create. This is almost like a shorthand, but it's probably not creating a new object for you. Like maybe you could create a new dictionary, but it's not creating like an example of a Porsche, I guess. We'll see a little bit more from here that we can add functionality to this, right? Like the same way that like a list, we create a new list. These are my students, right? And then a list has a method on it called append, students dot append, that every list allows you to append. Well, we can define functions on a class so that every, say, let's say turn on, every car now will have this function turn on. So it's basically like I think it's more like, this is like you're constructing a data type. You're defining a data type, right? So for instance, now we'll do Porsche. This is actually going to break. I'll show you. We'll have to make one little change to this. If I do this, Porsche dot turn on, right? It's going to say, okay, turn on is getting one argument. What you need to do actually is, and we'll talk about this later on in a maybe 10 minutes or so, you have to pass through this, define it with the word self. Okay, but just take a look at this. So you can see now, what are we doing? Most pieces of data don't have this function called turn on, but we in our class, we're saying now we want every instance to have the capability to turn on. So we define a function called turn on, right? And now when we initialize a new car, that car, we can call the function turn on, right? On that instance. Okay.
Hey Jeff, I think it's making sense, but what I'm asking is, if we have to explain the difference between class and function, how do you answer that question?
I mean, I would say a class defines it defines behavior. You know what I mean? Like this is it. Like basically objects. Normally people ask like maybe what is an object? And an object is both data combines both data and behavior. Where behavior is like the functions, okay, and the data are the attributes, right? So you can have functions, which is just like turn on and kind of anything turns on. But here, what you have is this particular type of object has this behavior. So you are kind of like scoping the behavior to this kind of piece of data, to these objects, right? Like it doesn't make sense to say, like, if we have another, right, a class called turtle or dog, like it doesn't make sense to have a function here called turn on. Like that doesn't make sense, right? So the point of like an object or a class is, okay, this kind of this type of object gets this kind of functionality, and it's going to be associated with this kind of data. The same way a dog would have, a breed or whatever. Here, a car is going to have, miles per hour or whatever. Like it will have different attributes. So this is a marriage between the attributes and the functionality.
Can you re-explain self? I just joined it at 3:10.
Yeah, we didn't talk about self yet.
Okay.
We will. We just need it. So far, all we know is, for whatever reason, we need self when we define our functions inside of a class. Okay? So the point so far is just, okay, we have this thing called a class. A class, you oftentimes hear the analogy to like a factory. Why is it a factory? Because it produces new instances, right? So if I do car parentheses, it produces a new instance. You'll also hear a class described as a blueprint. Why is it a blueprint? Because you're saying you're defining the blueprint of those instances. So in other words, you're saying, hey, each of these instances will have the ability to have this turn on method, right? And you're defining that functionality on the class, okay? The other thing we saw was just like data, the fact that each of these instances holds onto their own data, right? Like we wouldn't really give functions data, but an object has both data and function behavior associated with it. So Porsche.year we say equals 2010, and then we actually get back the Porsche.year. Okay. All right. So in terms of self, let's say we have, let's say we want to say like we'll just say like display color or something like that, or yeah, I guess that's fine. Explain, summarize attributes, or say color. This will be a little silly for now. Okay, so if we have this car, we have a method called sayColor. We want to, be able to create a new Porsche. Let me delete some of this stuff. Okay, so we create a new Porsche, and then we're going to do Porsche.sayColor. And what we want to have happen, let's give it a color first. So color is yellow. Okay, and what we want to have happen is that it will say something like the color is yellow, right? It will tell us the color of the car. Now the problem is that we're going to have is that we wanted to, if we change the color to red, right? Like we wanted to say the color is red. In other words, it's going to need a way to, if I change this to red right now, it's going to break because it's just hard-coded. The color is yellow. So how do we fix something like that? Now one way we can do it maybe is like have an F string and then put like Porsche dot color, but that doesn't work, right? Because it works for here maybe, but once I now create a new like Ferrari, and I do car, and now I do Ferrari dot color is blue, and then I do Ferrari dot say color, this is still calling Porsche. You know what I mean? So what do I want? Like what we really want is a way to refer to each individual object who's receiving the method call. So each object that we're calling this method on, I want a way to refer to this guy at this moment, and I want a way to refer to this thing at the moment that I'm calling this method. And the way you do that is with self. Okay? So self is the instance that receives the method call. So just to show you that, here I have Porsche. I'll do Porsche.color. This will be Porsche. You can see the color is red. And when I call Porsche.sayColor, self is going to refer to this particular car. So you can think of it as like we're passing this object through the method as an argument, and now I'll call Porsche.color, and it will spit out red. Porsche.color, red. Even though we don't have the word Porsche here, right? And now if I change this, Ferrari, here it says Ferrari.color. Because of that, we see it's blue. So we can maybe make this even more clear. Let's print out self. So I'll just show you this. So here's Porsche.
What if we pass the parameter as a color?
Yeah, let's build up to that. Give me 1 sec. We'll build up to that. So here we have a car, right? And here we have Porsche. And you can see it's 0x7 ends with 20. We'll do Porsche.color. Let's do now Porsche.sayColor. Right? Notice what's happening. We call this method. It's printing out self. And this, what is it? What is self? Self is this particular object, right? 0x7, whatever, 20. If I then call Ferrari, let's do it down here. We'll create a new Ferrari, do Ferrari.sayColor. This is no longer do we have that 20 at the end. Instead, what it's printing out is this instance, right? Why? Because when I call sayColor, self is whatever object receives the method call. So in this case, when I call Porsche.sayColor, self is this object. Okay? Here, down here, Ferrari, I call Ferrari.setColor, self refers to the Ferrari, because that's the object that receives the method call. So one way to think about it is what is to the left of the dot? Whatever instance is to the left of the dot, that is self, right? So here self is Ferrari, here self is Porsche, okay? If you want to, questions before I move on from there? If you want to like let's say we have, you want to like pass something through, like let's say we want to do like def, speed up or something, and we do self, and then increase speed. What can you do? We can, we can say self dot. Well, yeah, I guess we'll do it this way. We'll start with a Porsche. We'll say Porsche.speed equals 10. So given an attribute of speed is 10. And then we want to call Porsche.speedup. So what should this do? And let's say speed up by. So what do we want to do? So we want to pass through, if we pass through the number 5 here, we want to increase the speed by 5. So how do we do this? We will do return, we'll do this. We'll say the speed equals self.speed. So it's the instance's speed plus 5, plus the increase in speed. Okay? And then we can just return that for now. So we call this speed up by. We create a new Porsche. We set the speed to 10, right? So now Porsche.dunderdict has the speed of 10. Then we do Porsche.speedup by. And we pass through 5. And that would take the self.speed, so 10, plus the increase in speed, and that will return 15. Got that? Now what it did not do, if you call this again, it's going to stay 15 every time, even though it seems like we're increasing the speed. Right? It's not actually increasing this attribute. Like if you look at Porsche.dunderdict, it's staying at 10 the whole time. So what do we need to do? Like, why is that? Because you need to say self.speed equals the new speed. So here we are like performing the calculation, and here we're setting the attribute, updating the attribute on the instance. So now let's take a look at it. We call Porsche and Porsche.speed. So we have the speed is 10. And then we'll call Porsche.speedup by 5, get to 15. And now let's do Porsche.dunderdict. And this time we'll say 15. Right? So if we call Porsche.speedup by 5 again, this time I'll return to be 20. Okay? And if you look at the Porsche.dunderdict, you can see that that's now 20. So again, why does this happen? Well, it's just doing what you said. You said increase the speed on the object that receives the method call. So on this Porsche, get the speed. It will start off as 10 plus 5. That's 15. Set 15 equal to this variable. Now, take that attribute, right? Set an attribute or update the speed attribute on the particular instance to be 15, to be this value here, 15, and then finally return it. Okay, so in order to actually update the attribute on the instance, you need this dot, right? This is just a local variable in the method. If you want to update the instance, self dot, the attribute equals whatever value you want. How does that feel? Yeah. So what do we learn, right? We kind of learn like we're defining our... Go ahead.
I mean, we can pass the multiple parameters. Instead of just increase speed, we can have something else also.
Yeah. You can have as many as you want. Whatever. Increase speed, multiply speed, But the first argument is always self. Always. So now, how many arguments in total do you have to pass through? 2. because self is always implied, is always the first argument regardless, and then 2 additional arguments, right? So 2 arguments you'll pass through. Yeah, init, I saw Kumar ask a question about init. That we'll get into. There's a reading on that. We'll get into that next. But I want to, anything about this material so far?
I just had a quick question. So, how common is it where you're going to set attributes on the instance versus the class itself? I mean, it's
Normally, normally you'll set attributes on the instance and not on the class.
okay.
Because it's the instance like that. If you think about it, like it's the, you care about this car, like this particular car. You know, what is the attribute? You know, how fast does this car go?
Right. But I guess we'll get into it. I mean, I guess the class will have default things, though.
You can do that. I mean, so that you can do with init. That is actually where you would probably use that. So we can talk about that now. Let's do this. There's a special kind of method called init. Let me show you how this works. So I defined a method called double_init double_. All right, and again, it's a function. So every function has self as a first argument. Now notice what will happen this time. If I create a new Porsche, what's going to happen? A new car? It prints hello world. Why does it print hello world? Because every time an instance is created, it first runs this method call, init. Okay? Now, why is something like this useful? Well, let's say, we want to do what Ken is saying and say, okay, well, this is, we're creating these cars. We should kind of a car always has 4 wheels. So let's, give it that attribute every time. So this thing's always run, right? Init is always the first thing that's run. So it's going to run this function, set a new attribute of number of wheels equal to 4. So if I create a car, let's call this my Porsche. And now I look at Porsche.dunderDict, it sets that attribute, right? Because it's just running this function. Self is this instance, Porsche, and we're saying self dot number of wheels equals 4. The other thing you can do is you can say something like, all right, well, I don't want you to be able to even create a car unless you tell me what the color is. Like, it can't leave the factory unless you tell me what the color is. The color can be, you can specify it, but you have to specify a color. So we'll do self.color equals the color you pass through. So what's happening here? Here, we're going to, when we create a car, we're going to pass through the color as red, okay? This string is going to come through as the second argument, as this color argument. We're going to set the number of wheels to 4, and then we're going to set the color to whatever is specified here. This time the color is red, the number of wheels is 4. We change this to blue. I create a new instance. Let's call this my Ferrari. Now it's blue. So let's just see that. Why? Because we're passing through blue here. That string blue is coming through, right? The argument color now means the string blue. Now we're doing self dot, that instance, that Ferrari dot color, that attribute should be equal to that string, blue, right? In this case, we're just saying, okay, their number of wheels is always 4. So init, the only real thing it does is it's the first, when you initialize a new instance, init will be run. As long as you put the double underscores properly, it will be run. Okay? And then you pass through arguments by constructing, in the parentheses, you pass through the argument when you're constructing the object. If you forget it, it's going to break, right? It's going to say, hey, you need to tell me the color. Init is missing one required positional argument, color, because I'm not passing it through here, but this init function is saying we need it to create a car. You can pass through a default argument if you want, just like any other function. So now, if I pass through red, the Ferrari that's under Dick, the color will be red. If you pass through nothing, it will be blue. Why? Because when there's no argument passed through, right, it will take the default and set it to blue. Okay.
There should be only one init method, or we can pass another init method with different parameters.
There's only one init method in a class.
Okay.
Yeah. What's the best way to list all instances and their attribute in a given class? Good question, Brian. Listing all the instances is hard. You kind of have to do that. We can show you how to do that. Listing all the in instances attributes, you can do that right with this dunderdict. If you want to keep track of all the instances, you can do this. You can kind of write. What we'll do is we'll kind of create an outside variable. So we call it all cars, and have a list, right? And now what will we do? Every time you create a car, add it to this list. So we can say all cars dot append. Let's put this at the bottom. What do we want to add here? Self, the car that just got created. Right, so now you can kind of create a Ferrari, and if you look at all cars, that car we just created is in there. If I create a new car, Porsche, and I look at all cars again, now we have two instances here. Why? Because every time we create, this init thing gets called, it takes this list and it adds in the instance, this instance that were newly created. We'll build up to this. This is a little further down the line. All right, but I just wanted to show you. So what now you can loop through these and get called dunderdict on each of them if you want to, something like that.
Jeff, if you did append self.self, would it then put all the names of the cars?
Well, self.self, you mean self.name, something like that.
Self.name? Okay.
Yeah. So let's say if we did self.color, let's do that. Which is not what you want to do, by the way. What you want to do is just append the whole instance.
Yeah.
And then what I'd prefer you do is just loop through for car in all cars, car.color, something like that. And I guess I didn't. I'm surprised. Maybe there's no car. Hold on. There we go. Right. Go through each of the cars in the list. Return to me the color for each one. Something like that. Again, more advanced. You don't have to worry about that right now. We'll get there. But for now, we defined a class, right? A class we said is both a factory and a blueprint, right? Factory because it creates new instances. Blueprint because we define how these instances are going to work, right? With the methods. The car can now turn on, a car can say its color, can speed up, right? We're defining the functionality of each car here. We saw, you need this word self for every function. You're going to forget it, but when you forget it, you'll see that it'll say, hey, have the wrong number of arguments, so just put in the word self. Self is the instance that you're calling the method on, or really the instance that receives the method call. So here, speed up by 5, self inside the method, self is that Porsche, because this is what's to the left of the dot. When you go down to a Ferrari and call a method, say color, Ferrari now becomes self, right? When I inside this say colored method, Ferrari, right, is what's self, because that's in this moment, that's what we're calling the method on. Okay? All right. So I'll deploy that basically